So, we just learned one kind of bedding cleavage intersection, and we saw the trace of the bedding planes on the foliation or cleavage plane. Now, as I said that there is also another possibility that you have the trace of the foliation plane on the bedding surfaces. So, as this drawing we are familiar now. So, this is a bedding plane, and I said that this surface that we are seeing here, this is the extrados or form surface of this fold, and foliations would create intersections along this. So, if I draw this plane, the traces of the foliation should appear on the bedding plane, and this is also another type of intersection lineation. So, we also call this as intersection lineation, and this is trace of axial planar cleavage on bedding plane, or in other words we can say that axial planar cleavage is S1 and bedding plane is S0. So, trace of S1 on S0. Previously we have seen trace of S0 on S1. So, let us see how does it occur in the field. And what we see here, that this is again the same trace of the bedding plane, as you can see here. So, here you have, in this side you have sand rich layer, here you have mica rich layer, and this is the boundary of this plane, and here we see a nice plane is exposed. This is the bedding plane or the depositional surface, or S0 as we have defined. And on this surface you see there are numerous traces, and you can see that these traces are actually going this side, which we have identified these are the foliation planes or the cleavage planes. So, this is a bedding plane, and on this bedding plane we see the traces of the foliations or cleavage. So, these are also another type of bedding cleavage intersection lineations, or in simple words intersection lineations. And again, if you measure the trend and the plunge of this intersection lineation which are exposed on this bedding plane, that will give you also the fold axis. So, we have learned two of the most important intersection lineations. One of the primary thing that you need to know when you learn lineation and try to identify them in the field. One was trace of the foliations on the bedding plane, and another trace of the bedding planes on the foliation surface. Now, these two you see generally in low grade metamorphic rocks. In high grade metamorphic rocks you do not expect this bedding cleavage intersections. You may find cleavage intersection lineations, but in high grade metamorphic rocks the original S0, the primary layers, are generally destroyed due to extensive metamorphism, and therefore, the chances of seeing the bedding cleavage intersection is extremely less. In this particular exposure, we have seen the trace of the beddings on the foliation plane, and on this surface we saw the trace of the foliations on the bedding plane on a same place, positioning just side by side. How beautiful this could be for a structural geologist. So, what you are looking at here, this is again the surface S1, that means the foliation surface, and you can see the foliations are here like this. So, this is almost the foliation surface or at a very low angle. So, we see the foliation surface here, and as we just learned that on the foliation surface, if you find some other marks, for example, what you are seeing here, these lines, these are, we just learned, the traces of the bedding planes. Now, what we see here, as I repeat again, that these are the traces of bedding, because you see the thickness variation like here, like here. So, that tells you that these are traces of the primary layers. You can also see compositional variations, that also tells you that these are of primary origin. What I wanted to convey the message here is these lines, you see, they are appearing like bands on this foliation surface. So, when they appear like bands, like stripes, these are known then as striping lineation, or we refer them as striping lineation, because they appear as stripes. So, alternate color bands on the foliation surface, most likely on S1 surfaces. If you see them like this, these give you the striping lineation. These are nothing but bedding cleavage intersections. Needless to mention here that if you take the trend of this line, of these lineations, and the plunge, that will essentially give you what is the fold axis of this region. We are on the southern part of the river Subarnarekha in the location Ferryghat, and I am sitting on an exposure which is actually a foliation plane, or S1. This foliation plane here strikes east west and dipping towards north, dip angle is around 40 degrees. This surface displays two very interesting lineations. One, as you can clearly see, that it has like a wrinkling pattern, and wrinkle axis is along this plane. And if you see closer, you will see that this apparently shadowed area that we see here is actually quartz rich, and this one is mica rich. And this is how they are forming this excellent lineation on the surface, which is trending like this, and this is one of the very typical crenulation cleavage. Now, why I am saying this crenulation cleavage? Because I have seen it on the thin section, and I know that this quartz rich layer or quartz feldspar rich layer, quartzo-feldspathic rich layer, it has fabric inside it. So, microlithons with fabric in a cleavage area is a crenulation cleavage. So, this is very beautiful crenulation cleavage that you see on the surface. There is one more important lineation that we see on this surface together with this crenulation. We see that you see these little dots here and there. These little dots are garnets, which are porphyroblast in this rock, and they are mostly post-tectonic. A few are syntectonic garnets in this rock. What is important or interesting in this rock is that these garnets, around these garnet grains, some pressure shadows have developed along a particular direction, and that gives you this kind of lineation which has an orientation in this form, in this, along this line, and this is known as pressure shadow lineation. So, we will see how these pressure shadow lineations do form, and also what are the mechanisms of pressure shadow lineation. Imagine that these are some garnet grains. Which was growing like a porphyroblast during metamorphism, and then of course you may consider that compression is coming along this direction. So, the overall trend of foliation would be like that. Around this garnet the foliation would wrap like this, because one cannot develop foliation over garnet because these are strong minerals. So, interestingly, in this domain, as you can see, this area and this area, they are appearing as shadow zone. And these are low pressure zones. So, here minerals like quartz, they deposit, and their grain size is slightly larger over the other grains in the matrix. So, these are known as pressure shadow zones. And you can see that if you have numerous garnet grains and you have pressure shadows, so they eventually give rise pressure shadow lineation. As you can see, we have zoomed this area. This coin would give you an idea of the scale we are looking at, and you see the garnet grains, individual garnet grains here, 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 all along, and also the crenulations are here. Now, if I follow a particular garnet grain, you see it has a different composition along this direction, down deep of the foliation plane. So is here, and in all garnet grains you see a shadow on both sides, and these, when we view them, they appear like a lineation, like a linear feature, and this is a penetrative lineation, and we assign or we call them as pressure shadow lineation. So, clearly you see, if this is the crenulation cleavage, this is a trend of the crenulation cleavage, then we can say grossly that the compression direction was along this pane. Okay? If we see the pressure shadow lineation along this direction, then probably compression direction is along this plane. So, you see that looking at a very tiny area, one can figure out or one can tell easily that the orientation of the principal axis of stresses did vary in this region, and we will explore it with time why and how did this happen. We are looking again at the S1 surfaces here. So, you can see that these are foliation S1 surfaces. And on this surface we have already seen two different lineations in other places. So, these are also present here. The first one is the crenulation lineation that goes like this. The other one is the pressure shadow lineation. So, you can see this etc. These are garnet grains, and pressure shadow lineation here is like that. Other than these two, there is also one mineral lineation that we see here. You see this little blocky rectangular grains here, 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 here and so on, here and here. These are biotite grains, biotite porphyroblasts in this rock, and they also define a lineation along this direction. So, these pressure shadow lineations are like this, the crenulation lineations are like this, and biotite mineral lineations are like this. So, we have just seen these three surfaces and identified three different mineral lineations, and if we just look little wide, we see also another lineation that we have already marked or already learned, that is, you see the striping lineations on this surface. So, these are also subparallel surfaces of the S1 or foliation plane. So, striping lineation goes like this. Then we have crenulation lineation, which are like this here. At this trend you can see it here. So, let me place it properly. Then we have pressure shadow lineation, which are defined by occurrence of garnet and the shadows on the both sides of the garnet grains. So, these are the garnets here, here, here and all along, and their orientation, the pressure shadow orientation is like that. Then we have mineral lineations defined by the biotite grains and their orientation here. Let me place it properly somewhere so that you understand. I hold it like this. So, you can see the lineations are like this, and I am holding it in this form. So, you see how beautiful is this little exposure and how many information you can extract to interpret the regional deformation. First of all, we are looking at a foliation surface, which we have identified as continuous foliation, and this is S1. Then we have found the traces of the primary bedding plane S0 on this surface, which is marked by the yellow sketch pen. That gives you the intersection lineation. Then this foliation surface S1 got crenulated, and this crenulation axis is this. So, this is crenulation lineation, which is marked by this black plane. Then we have pressure shadow lineation marked by this pink sketch pen, and finally, the mineral lineation, which is along this blue plane. So many information from a single place. We will measure them at different places differently, and we will plot them on the stereo net, and we will figure out if they are mutually related or not when we will interpret the regional deformation. So, now if we review this area that we looked at, we see that this is the foliation surface S1, and we also can see that this S1 displays two major lineations. The primary one that we have seen was the crenulation lineation. So, the trend of the crenulation lineation is like that. So, this surface is horizontal, then here it is almost subvertical, and then this is again horizontal. So, the horizontal surfaces represent S1, and this is kind of a cross section of this area. of the S1. So, on this surface you see the traces of S1 going like that, and these were the traces of crenulation cleavage. So, in this surface we should see the traces of the crenulation cleavage, and what we saw here, this bands, alternate bands of shiny and grey, which did represent micaceous layer and quartz feldspar rich layer respectively. In this side you also see these bands are coming like this. So, these are mica rich layers here, here and here, and they are appearing as spaces. So, these are essentially spaced cleavage. And what we see more importantly, because these are crenulation cleavage, so there should be some kind of microfolds. So, if you look carefully, you actually can see, if you follow the tip of the pen, you can see the folds. Therefore, these are giving rise, I am drawing some lines here. Penetrative planes over a surface. So, these were S1 primary foliation and these are S2. Now, the S1, as we have understood, these are continuous cleavage, but S2 here is spaced cleavage, which are being developed by the crenulation of S1. What is most important to look at, and that is why I have selected this exposure for you. This one is S0, which is striking almost north towards this direction, north south, and these are the traces of the S1 foliation plane, and these are dipping towards northwest. So, these are the foliation plane, as you can see, plane of S1. Now, this S1 surfaces, if you look carefully, you see that they are giving some kind of folds, very small folds, and these we have identified as crenulations. So, we do not see the crenulation itself or crenulation lineation here in detail, because S1 surface is not very well exposed, but the S1 surfaces, the primary foliation surface here S1, these are crenulated, and because of their tight crenulation we expect a spaced cleavage, right, and that would give rise S2. So, if these are the folds, tiny little folds that we see here and there along this S1 or over the S1 surface, their traces go like this, and these are the S2 of this area. So, we see these are, this is the trace of S0, we see this is the trace of S1, and we see this is the trace of S2. Now, we will take the measurement of all these data, all these surfaces. We try to find out the relationship, that means intersection lineation between S0 and S1, the intersection lineation between S0 and S2, and the intersection lineation between S1 and S2, and all these in combined form will give us the fold axis F1, F2, and we will figure it out that how these F1, F2 are related here, and at the same time we will compare, because we are far from our first location Ferryghat, that how this S1 and S2 are related here, how the F1 and F2 are here, and how whether it has deviated from our measurement from Ferryghat or not. With this I end this lecture, lecture number 8. and I thank you all for listening to this, and I believe you now slowly are developing an orientation towards understanding or securing a confidence that if you go to the field, you can identify different type of structures, be it primary or secondary, and once you identify those, you can interpret several other information out of this. So, we learned primary structures, we learned sedimentary structures. In the next lecture, what we will talk about is we will take a particular litho unit, and this litho unit would be the first quartzite band. So, we will start from the Chitrakoot hillock and slowly move towards the Subarnarekha river, and while we are moving, we will take data from different locations, mostly data of the bedding plains, and we will see how this first quartzite band is disposed in and around the Harindungri village. We will plot these data to StereoNet, and we will also plot this data in the topo map. In other ways, we are going to learn for the first time in this course the lithostructural mapping. So, stay tuned, we will come back in the next lecture. Thank you.